Hello everyone, welcome back to the session. See, this is the last topic under the unit amines, that is electrophilic substitution reactions of aniline. Electrophilic substitution reactions of aniline. Aniline means it is an aromatic amine. Now, before explaining electrophilic substitution reactions of aniline, what do you mean by electrophilic substitution? See, in first PUC we have studied electrophilic substitution reactions of benzene. See, benzene undergoes chlorination, bromination, nitration, Friedel-Crafts alkylation and acetylation, and also sulfonation, correct? Then what is electrophilic substitution? Electrophilic substitution means replacement electrophilic substitution means what? Replacement of hydrogen atom. Replacement of hydrogen atom of a benzene molecule by, it is replaced by an electrophile. So, replacing hydrogen atom of a benzene by what? By an electrophile. By what? By an electrophile. It is called as what? It is called as electrophilic substitution reaction. Can you tell me the definition of electrophile? What are electrophiles? Electrophiles are electron deficient species. Electrophiles are what? Electron deficient species, and they are capable of accepting the electrons, accepting the pair of electrons. They are capable of accepting the electrons. So, these electrophiles, since they are electron deficient, they always attack. Where do they attack? They always attack to the electron rich center. Their attack will be on what? On the electron rich center. See, benzene undergoes electrophilic substitution. To the benzene ring, electrophile will readily attack. Why? See, electrophile can, generally we can write it like this. It is E plus. Electrophile carries positive charge. It is electron deficient. It can readily attack this ring, hexagonal ring. Why? Because in benzene, pi electrons, they are involved in what? They are involved in resonance. As a result, these ortho and para position, this position we call it as ortho, this is para. So, ortho and para position becomes what? It becomes electron rich, or electron density increases at ortho and para position. Therefore, electrophile can readily attack that position, that is ortho as well as para position. So, this is the reason why benzene undergoes electrophilic substitution reaction. Aniline, structure of aniline, it is like this. See, this is aniline. In aniline, nitrogen contains lone pair of electrons, and these lone pair of electrons, they are donated to the benzene ring. As a result, resonance takes place. So, due to resonance, I can write the resonance structures. Here there is negative charge, double bond, NH2 plus. This is a second resonance structure. Again there is double bond, NH2 plus. So, these are what? These are the resonance structures of aniline. So, in aniline there is one activating group, or we call it as electron donating group. This is electron donating group, or it is also called as activating group. Why it is called as activating group? It activates the benzene ring. By donating what? By donating pair of electron. So due to the donation of pair of electrons, electron density increases. You can see negative charge here. This position we call it as ortho position. This position it is para position. Again this is ortho position. Ortho means 1-2 position. 1-2 position it is ortho. 1-4 it is para. 1-3 it is called as meta. So this is 1-2. So this is ortho. 1-4 this is para. Again this is 1-2. This is also ortho. So due to the donation of electrons, benzene hexagonal ring or cyclic ring becomes what? It becomes electron rich, or electron density increases at ortho position and para position. So since electron density is more at ortho and para position, electrophiles, that is electron deficient species, can readily attack these positions, ortho position and para positions, forming ortho product and para product. So aniline undergoes electrophilic substitution reaction. What is the reason? Because in the case of aniline, there is nitrogen which contains lone pair of electrons, and these lone pair of electrons, they are involved in resonance. Due to resonance, electron density increases at ortho position and para position. So electron density increases at ortho and para position. So since electron density is more at ortho and para position, electrophile can readily attack ortho and para position, forming ortho product and para product. So electrophile prefers ortho position and para position because at ortho and para there is negative charge. So positively charged electrophile gets readily attracted towards negative center, that is ortho position and para position. So when an aniline undergoes electrophilic substitution reaction, products formed will be ortho para products. Ortho para products. Now let us take up the reactions, electrophilic substitution reactions. So first reaction, electrophilic substitution reaction, bromination. Bromination of aniline. Bromination of aniline. What is bromination? Bromination means replacing hydrogen. Hydrogen atom of benzene by bromine. Replacing hydrogen atom of a benzene ring by what? By bromine. It is called as bromination. For bromination we need bromine molecule. So for bromination we require bromine molecule. Let us write the equation. This is aniline. When it is subjected to bromination, by adding bromine molecule, that is bromine in water, this is called as bromine water. It is called as what? Bromine water. So aniline treated with bromine water. Now bromination occurs. What is bromination? Replacing hydrogen by bromine. Now here electrophile present in this, that is Br plus. What is that electrophile? Br plus. I won't explain the mechanism here. So it is Br plus, and this Br plus prefers what? It prefers ortho, because ortho there is what? Negative charge. At para there is what? Negative charge. Again at ortho there is negative charge. So Br plus readily attacks what? It readily attacks ortho, para, ortho positions. Ortho, para, ortho positions, that is ortho hydrogen gets replaced by bromine para position gets replaced by bromine. Again here, this is also ortho, it is also electron rich. This ortho position, it is also replaced by bromine. So totally we need 3 molecules of bromine, 3 molecules of bromine. So byproduct, it will be HBr, 3 molecules of HBr. So aniline reacts with bromine water, or aniline when treated with bromine water, a white precipitate of, what is this, 2,4,6, white precipitate of 2,4,6 tribromo. There are 3 bromine atoms, 3 substituent groups, bromo, tribromo, aniline. Tribromo aniline is obtained. So aniline undergoes bromination in the presence of bromine water to form what? To form a white precipitate, white precipitate of what? 2,4,6 tribromo aniline, and this reaction, it is taking place at room temperature. It is taking place at what? At room temperature. Hope it is clear. See, aniline treated with bromine molecule, replacement of hydrogen. Which hydrogen? Which positions are electron rich? Ortho positions and para positions. So ortho hydrogen, para hydrogen, one more ortho hydrogen readily gets replaced by what? By bromine atom forming 2, see, this is carbon number 1, correct? This is 2, this is 3, 4th one, 5th one, 6th one. It is 2, 4,6, 2,4,6 tribromo. There are 3 bromine atoms, correct? So it is tribromo aniline, 2,4,6 tribromo aniline. Now this product, if you observe it clearly, this product, it is what? It is a tri-substituted product. What is this? Tri-substituted product. Suppose if I want to prepare a mono-substituted product, mono means containing only one substituent group, containing only one substituent group. Suppose if I want to prepare a mono-substituted product, then what I have to do is, first I have to decrease the activating nature of amino group. Now what is the problem actually? See, amino group, it is highly activating group, highly activating group. It readily donates its electron to the benzene ring. As a result, electron density increases at ortho and para positions. Therefore we are getting what? Therefore we are getting tri-substituted product. We are getting what? Tri-substituted product. So we want, if we want to prepare a mono-substituted product, mono means ring containing only one substituent group, that is para product or ortho product. In that case, first what we have to do is, we have to decrease the electron donating tendency of nitrogen, electron donating tendency of nitrogen, or we have to decrease the activating nature of nitrogen. So after decreasing the activating nature of nitrogen, then we have to carry out the bromination. Let us explain that. So to prepare mono substituted product or mono substituted aniline, what we have to do? First, aniline, this is aniline, its activating nature must be decreased, or its electron donating tendency must be decreased. How? By carrying out what? By carrying out acetylation using acetic anhydride. Acetylation using acetic anhydride in the presence of a base, that is pyridine. That is what? That is pyridine. So, aniline subjected to acetylation using acetic anhydride in the presence of pyridine. What is acetylation? Replacing hydrogen by acetyl group. Replacing hydrogen by acetyl group. Formula of acetyl group, it is CH3 C double bond O group. CH3 C double bond O group. This group it is named as what? It is named as acetyl group. What is this? Acetyl group. Okay, so aniline treated with acetic anhydride, this aniline will undergo acetylation. It will undergo what? Acetylation. So, one of the hydrogen, totally here there are two atoms of hydrogen. One hydrogen gets replaced by acetyl group. I will rub this. So, here NH, H gets replaced by C double bond O, CH3. So, hydrogen gets replaced by acetyl group. So, this is acetylation. This compound it is named as, what is this? This is a substituent group present upon nitrogen. So, this is N-phenyl. Ring it is taken as what? When it is considered as the substituent group, we have to write phenyl. So, it is N-phenyl. What is this? N-phenyl. Total number of carbon atoms here it is 2. So, it is N-phenyl ethanamide. N-phenyl ethanamide. It is also called as, in the last sessions I told you, it is acetanilide. One more name. N-phenyl ethanamide, or it is acetanilide. Now, if we carry out acetylation, activating nature or electron donating nature of nitrogen decreases. Now, its electron donating tendency is less. Why? See, now nitrogen it is bonded to carbonyl group. Nitrogen it is bonded to what? Carbon. This is carbonyl group. This group it is called as what? Carbonyl group, and this group it is electron withdrawing group. What is this? Electron withdrawing group. So, what happens? Lone pair of electrons will be shifted towards what? Towards the oxygen atom of carbonyl group. Towards what? Oxygen atom of carbonyl group. As a result, electron donating capacity of nitrogen decreases. Initially, when it was free, it was it was going into what? Into the benzene ring. Now, if we carry out acetylation, what happens is, so directly it cannot donate the electron to the benzene ring, because partially electrons are attracted by what? By the electron withdrawing group. So, some amount of the electrons will be shifted towards what? Towards the carbonyl oxygen atom. As a result, electron density upon nitrogen decreases, or its activating nature decreases. So, now it cannot readily donate its pair of electrons to what? To the benzene ring. So, activating nature it is decreased. So, this is the first step. First step, that is acetylation. Next, second step. Now, we are carrying out bromination in order to get mono substituted product. So, bromination it is carried out by adding bromine in acetic acid. Bromine in acetic acid. By adding bromine in acetic acid, this acetanilide it is subjected to bromination. So, this group remains as it is. It is NH C double bond O CH3. Bromination means replacing hydrogen by bromine. Replacing hydrogen by bromine. See, para hydrogen gets replaced by bromine. Why not orthohydrogen? If I replace orthohydrogen by bromine, see, these groups are very close to one another. NHCOCH3 and Br, they are very close to one another. So, distance it is less. So, steric repulsion will be more, or electronic repulsion will be more. So, due to steric repulsion, stability decreases. So I would prefer, I'll prefer what? Para position. That is Br. Where did I wrote? At the para position. So this is para position 1 4. So bromination occurs at para position. So first step is acetylation. Second step bromination by adding bromine in the presence of acetic acid. Last step, see, to remove this group, to remove this acetyl group, I have to carry out hydrolysis. I have to carry out what? Hydrolysis, either by adding an acid or by adding a base. Either by adding an acid or by adding what? By adding a base, I have to carry out hydrolysis. Thereby, I have to convert this group NHCOCH3 must be converted to NH2. So here NHCOCH3, in this group hydrolysis takes place here, correct? Because this bond, it is a polar bond which is present between carbon and nitrogen. It is a polar bond. Carbon, it carries positive charge, partial positive charge. Nitrogen carries partial negative charge. So I can write delta plus and delta minus here. So since there is a positive charge upon nitrogen, H plus will be added here. H plus of water, OH minus it is added to carbonyl carbon. OH minus it is added to what? Carbonyl carbon. I will write it neatly. See, this is NH C double bond O CH3. This bond will break. H plus it is added here. OH minus it is added to carbon. Because carbon carries positive charge, so negative ion. Nitrogen carries negative charge, so positive ion it is added to nitrogen. Thereby it is converted to NH2. This is Br. Byproduct, that is CH3, C double bond O, OH, or it is CH3, COOH, acetic acid. Can you name this compound? This is 1, 2, 3, 4. It is 4-bromo. What is this? 4-bromo-aniline, or it is para-bromo-aniline, and this is what? What is this? Mono-substituted product. Mono-substituted product. So in order to get a mono-substituted product, in the case of aniline, first we have to carry out acetylation by adding acetic anhydride. Why acetylation? To decrease the activating nature or to decrease the electron donating nature of nitrogen. Acetylation is carried out. Upon acetylation, NH2 group gets converted into NH C double bond O CH3, NH C double bond O CH3. Thereby electron donating tendency decreases due to the presence of electron withdrawing carbonyl group. So partial electrons will be shifted towards carbon. As a result, electron donating tendency of nitrogen decreases. Ring becomes what? Electron rich or less electron rich? Now it is less electron rich. So next we are carrying out bromination in acetic acid. Bromination occurs at para position because this is stable compared to ortho. So Br, hydrogen gets replaced by Br at para position. Finally, to convert this group once again to NH2, we are carrying out hydrolysis either by adding an acid hydrolysis, or alkaline hydrolysis, means either by adding dilute solution of an acid or by adding aqueous solution of a base. So bond breaks here. This polar bond will break, forming para-bromo-aniline along with acetic acid. This is about bromination of aniline. Next one, second one, nitration of aniline. Now what is nitration? Nitration means replacing hydrogen by nitro group. Replacing hydrogen by nitro group. For nitration we need nitric acid, HNO3, along with HNO3 sulfuric acid it is also added. This mixture it is called as nitrating mixture. So nitration, what is nitration? Replacing hydrogen atom of a benzene ring by nitro group. This reaction it is named as nitration. Nitration, for nitration, to bring about nitration we have to add concentrated nitric acid along with concentrated sulfuric acid. This mixture it is called as nitrating mixture. Now here I will write aniline. This is aniline. When it is subjected to nitration directly, when it is subjected to nitration directly by adding nitric acid and sulfuric acid at a temperature of 288 Kelvin or 15 degrees Celsius, along with the nitration products, along with the nitration products will get tarry oxidation products. Tarry means black mass will be formed. So along with the nitro derivatives, tarry oxidation products will also be formed. This is because nitric acid it is not only a nitrating agent but also a stronger oxidizing agent. Nitric acid it is not only a nitrating agent but also it can act as what? It can act as an oxidizing agent. So we will get oxidize the product also, tarry oxidation product, or black mass will be formed due to oxidation. That is when we carry out nitration of aniline directly. So aniline subjected to nitration directly by adding nitric acid and sulfuric acid at a temperature of 288 Kelvin. Products obtained are, see this is aniline, nitro group, that is at para position, this is at meta position, one more ortho derivative. What is the name of this compound? This is 1,4. 1,4 means it is para. This is para nitro aniline, nearly 51% will be formed. This is meta nitro aniline. Meta nitro aniline, nearly 47% will be formed. This is 1,2 position, this is 1,3, so it is meta. 1,2, this is ortho nitro aniline. Ortho nitro aniline only 2%, only 2%, totally 100, correct. 51% of para product, 47% of meta, 2%, that is of ortho derivative, ortho nitro aniline. If you observe these products, ortho product, meta and ortho para and meta, a question must arise in our mind. What is that question? Why do this meta derivative exist along with para and ortho? See, we know that in aniline only ortho and para positions are electron rich. Ortho and para positions are electron rich. So electrophile, that is NO2 plus, nitration, in the case of nitration, electrophile, that is NO2 plus, nitronium ion. This electrophile, it has to attack ortho and para position only, ortho and para position. Now, why this product exists? Meta product, meta nitroaniline, nearly 47% will exist in the medium, correct? So, why this compound exists? That we have to explain. See, meta product exists because I will write it here. We are using for nitration, we are using stronger acidic condition. We are using what? Stronger acidic condition, stronger acids, nitric acid and sulfuric acid. Now, what happens is, under stronger acidic conditions, aniline being a base, aniline it is basic in nature or it is a Lewis base. Aniline being basic readily accepts H plus ion. These two, they are what? They are acids. Acids readily produce H plus, correct? HNO3 produces H plus, H2SO4 also produces H plus ion. So, aniline being a base readily accepts the proton. H plus it is named as proton. So, it readily accepts the proton from the acid, forming, it is by donating lone pair of electron, it will accept H plus, thereby NH2 becomes NH3, there is a loss of lone pair, so plus NH3 plus, this is anilinium ion. What is this? Anilinium ion. See, in anilinium ion, this anilinium ion will undergo resonance, correct? That is not plus R, it is minus R, like this. Since it is electron deficient, pi electrons will be shifted like this. This position becomes electron deficient. These electrons will be shifted to the upper position. Again, this becomes electron deficient. Once again, pi electron shift takes place. Again, this is positively charged. So, in anilinium ion, ortho para positions, they are electron deficient. Only meta position, it is somewhat electron rich. Meta position, it is what? Electron rich. So, when we carry out nitration along with the aniline, anilinium ions also, anilinium ion will also be seen, or it is generated. Anilinium ion, it is generated in the medium. Along with the aniline, we can see what? Anilinium ion due to acid base reaction. Aniline, it is a base, these are acids, correct? So, aniline readily accepts the proton from the acid, forming anilinium ion. Actually, we took aniline, along with the aniline, anilinium ion will also will be generated. It will be generated, and this anilinium, in this anilinium ion, meta position, it is electron rich. So, electrophile attacks meta position. What about aniline? In the case of aniline, electrophile attacks at para and ortho. This is para, this is ortho. This product, it is obtained due to the existence of what? Anilinium ion. In anilinium ion, only meta position, it is electron rich. So, to that meta position, NO2 plus will attack, electrophile will attack, forming meta nitroaniline. Meta nitroaniline. Hope it is clear. So, during nitration, we will get para derivative 51%, meta derivative 47%, and 2% of what? 2% of what is this? Ortho derivative. Now, once again, same thing. In order to obtain mono substituted derivative or mono nitro derivative, this aniline, first it is subjected to acetylation, using acetic anhydride in the presence of pyridine. What is acetylation? Replacement of hydrogen. Out of two hydrogens, one of the hydrogen gets replaced by acetyl group. This is acetanilide. Next step, nitration by adding nitric acid and sulfuric acid at a temperature of 288 Kelvin. At a temperature of what? 288 Kelvin. Now, nitration occurs. This group remains as it is. This is slightly deactivating group. So, nitration occurs at para position because it is stable compared to ortho. So, para nitro acetanilide. What is this? Para nitro acetanilide. This is acetanilide. What is this? Para nitro acetanilide. It will be formed in the next step. First step acetylation, second step nitration, last step hydrolysis, either by adding an acid or by adding a base, that is to convert this group NHCOCH3 group to NH2 once again. So, bond breaks here, H plus it is added to nitrogen, OH minus will be added here. So, formed product will be, this becomes NH2, here there is nitro group, byproduct it is CH3, COOH, name of this product, this is 1, 2, 3, 4, this is 4 nitro aniline, 4 nitro aniline, or it is para nitro aniline, para nitro aniline, or it is 4 nitro aniline. So, this reaction it is about preparing mono substituted derivative, that is in the case of nitration. Last one, sulfonation. Sulfonation of aniline. Sulfonation of aniline. What is sulfonation? Replacing hydrogen by sulfonic acid group SO3H. Replacing hydrogen by sulfonic acid. It is called as sulfonation. For sulfonation, we need sulfuric acid. We need what? We need sulfuric acid, concentrated sulfuric acid. Okay. So, aniline, this is aniline. When it is subjected to sulfonation by adding sulfuric acid, H2SO4, instead of sulfonation, acid base reaction takes place. Aniline it is a base, sulfuric acid it is an acid. So, actually we added sulfuric acid to bring about sulfonation. So, instead of sulfonation, what happens? Acid base reaction takes place. So, a sulfuric acid is an acid, aniline it is the base. So, acid base reaction takes place. Sulfuric acid upon ionization produces what? H plus then HSO4 minus. HSO4 minus. In aniline, nitrogen contains lone pair of electron. It readily accepts the proton because it is a base. Acid always donates the proton, base always accepts the proton. Accepts what? Accepts the proton. So, after accepting the proton, NH2 becomes NH3. After accepting a proton, it becomes NH3. Due to the loss of lone pair, we have tried plus here, NH3 plus HSO4 minus. HSO4 minus, this is salt. Acid base reaction always results in what? Results in the formation of a salt. Now, what is the name of this compound? Benzene ring containing NH2, it is aniline. Benzene ring containing NH3 plus, this is anilinium. What is this? Aniline. Next we are having hydrogen. So it is hydrogen. SO4 means sulfate. Aniline, hydrogen sulfate, and it is a salt obtained due to what? Due to acid base reaction. Acid base reaction. Next, this salt, it is heated up to 453 to 473 Kelvin. It is heated to 453 to 473 Kelvin. This salt will undergo decomposition, liberating. What is added here? Sulfuric acid. Liberating sulfuric acid. Upon heating, it will liberate sulfuric acid. Due to that sulfuric acid, sulfonation occurs at para position. Hope you can follow this. See, this is aniline hydrogen sulfate. We are heating it. Upon heating, added species will be removed. What is added? H plus and HSO4 minus, or it is H2SO4. So H2SO4 will be removed. Once again, this group will be converted to NH2 only. So added species it is removed. This is NH2 only. Because of this liberated sulfuric acid, sulfonation takes place at para position. That is SO3H. Sulfonation means replacing hydrogen by sulfonic acid group, hydrogen sulfate. This is sulfonation occurs at para position. Name of this compound. See, there are two functional groups. One is amino, other one is sulfonic acid group. Out of these two, priority goes to what? Priority goes to sulfonic acid. Goes to what? Sulfonic acid. So this is considered as the functional group, and this is substituent group. NH2 becomes what? Substituent group, and this substituent group, it is present at 1,4 position, correct? So it is para. It is para amino. Para amino. What is this ring? It is benzene. Para amino benzene sulfonic acid. Para amino benzene sulfonic acid. It is also called as sulfanilic acid. Also called as what? Sulfanilic acid. Now this sulfanilic acid in the aqueous medium, not in the aqueous medium, it exists as a dipolar ion. Exists as what? Dipolar. Di means what? Di means two. Polar means charge. Dipolar means containing both positive charge as well as negative charge. Means it is a neutral species. And this dipolar ion, it is called as Zwitter ion. This ion, it is named as what? Zwitter ion. So this molecule, sulfanilic acid, exists as a dipolar ion or Zwitter ion in an aqueous solution. This is due to the presence of both SD group as well as basic group. Sulfonic acid, it is an SD group. NH2, it is a basic group. So due to the existence of both basic as well as SD group, this molecule inside internally proton transfer takes place from sulfonic acid group to NH2. So proton, this is acidic, correct? It will liberate H plus. So remaining group it is SO3 minus. This H plus will be accepted by the base, that is NH2. It becomes NH3 plus. Now this molecule contains what? Both positive charge as well as negative charge. This ion, it is dipolar ion, or it is also called as Zwitter ion, and it is electrically neutral. Electrically neutral, and formation of dipolar ion, it is seen only in an aqueous solution. So sulfanilic acid exists as a dipolar ion or Zwitter ion, exists as a dipolar ion or Zwitter ion due to the presence of basic and SD group in the same molecule. Basic and SD group in the same molecule. Last one more point I have to tell. Aniline does not undergo Friedel-Crafts alkylation as well as acetylation. Aniline does not undergo Friedel-Crafts reactions, that is Friedel-Crafts alkylation and Friedel-Crafts acetylation. Why? See, in Friedel-Crafts alkylation we are using aluminium chloride as the catalyst. Aluminium chloride as the catalyst, and this aluminium chloride, it is a Lewis acid. What is this? Lewis acid. Definition of Lewis acid. Lewis acid is the one which readily accepts pair of electron. What about aniline? Aniline, it is a Lewis base. Lewis base means readily donates pair of electron, because upon nitrogen there is a lone pair of electrons, and these lone pair of electrons can be readily donated to Lewis acid. So during Friedel-Crafts reaction, we will add what? Aluminium chloride, which is the Lewis acid. This Lewis acid readily reacts with the Lewis base, thereby a salt will be formed. Acid base reaction always forms a salt, that is NH2 plus due to the loss of lone pair, AlCl3 minus, AlCl3 minus, NH2 plus AlCl3 minus. This is the salt. See, in this compound, nitrogen carries positive charge. Nitrogen carries positive charge. So because of this positive charge, or due to electron deficiency, it cannot activate the benzene ring, or this is deactivate. This becomes a deactivating group because of the presence of positive charge upon nitrogen. This group becomes what? It becomes deactivating group. As a result, aniline cannot undergo Friedel-Crafts alkylation as well as acetylation. So because there is no lone pair of electrons, it cannot activate the benzene ring. Instead, it is what? It is a deactivating group due to the presence of positive charge upon nitrogen. This positive charge, it is created due to acid base reaction. Aluminium chloride, that is a catalyst used in Friedel-Crafts reaction. It is a Lewis acid, readily reacts with the Lewis base, forming a salt. In that salt, nitrogen carries positive charge. If it carries positive charge, it becomes meta-directing group. It cannot be a ortho-para directing group. So this is meta-directing group, or it is deactivating group. So this is the reason why aniline does not undergo Friedel-Crafts alkylation and Friedel-Crafts acetylation. Thank you.